Now let's look at the first example problem for this topic, septuple sums. So we use this example to introduce the concept of array, but along the way we also discuss other programming idioms. So here's the problem statement. You are given 9 numbers and you are asked to find the 7 of the 9 numbers so that their sum is 100. And it's guaranteed that there are at most one such septuples. So septuple means a tuple of seven things. So there's only one such 7 septuples that will sum to 100, or either 1 or 0. And if they're 0, then you should output no such septuple exists. Otherwise, you output the septuple. So look at this sample example. So these are the 9 numbers. And as it turns out that these 7 will sum up to 100. So essentially we have 1, 2, 3, 4, 5, 6. So they sum up to 21. 6 plus 1 times 6 divided by 2 to 21. So then this will sum up to 100. And the other 2 numbers are 7 and 8. So there's no way that 7 and 8 can be involved to sum up to 100. So in order to solve this problem, we need to store the 9 numbers. And then we'll be going through these 9 numbers multiple times because we need to check combinations of them. So far, all the only concept we have taught in this course for storing values is to use variables. So then we will need to use 9 different variables. For example, we can call them A, B, C, D, E, F, G, H, I, and then we can write out our code to check for combinations, any 7 of them, whether they sum up to 100. So I guess it's actually doable for this question because 9 is not such a big number. So 9 choose 7 is the same as 9 choose 2. So that's 45. So we just need to write out all the 45 combinations of the 7 number of them, and then we sum them up and check whether they are 100. If it is, then we output that those numbers. So it's actually doable, but the code will be very tedious, and it's kind of messy because you have a big screen of all this jumbo code, and also if you are you're going to copy portions of it and then modify, and that's a very error-prone way of writing code, is to copy some portion and then change it, because sometimes you miss changing some part of it, and then it's a sort of difficult to figure out what went wrong. So anything that's tedious, that's repetitive, we are no competition for computers. So anything that's tedious and repetitive, we should let computer do it. We shouldn't be doing it ourselves. So in order to do that, here we need to use the concept of arrays. So array will store many values of the same type, and each one of the value can be accessed using an index. So it's like you have a row of rooms and you put in numbers into the room, and then each room have a number. Then you can reference to the number in each room using the room number. And array indices start from 0. So this is one thing that's very common in programming, is a lot of time we start from 0 instead of starting from 1. So to declare an array of 9 integers, this is the syntax. So we write int, and then the name of the variable, the array variable, and then square bracket, and then the size of the array here. So what this tells the computer, or rather the compiler, is I want to declare an array with 9 integers. And then these 9 integers later will be accessed using A0, A1, up to A8. So conceptually, you can think of these as A with square bracket something, that will be an integer. So we're basically telling A because you add square bracket to after a, you get an integer, then a by itself is an array of integers. When we initialize the array, we need to tell what size it is, because the compiler actually allocates memory to store this array. So the strength of array come from the fact that we don't have to use a constant value here as indices to access array element. If that's all we can do, then array doesn't offer that much more beyond using different name variable. I could call this A1, A2, A3, and so on. But because these indices can be expressions, then this enables so much more for in terms of writing program. So for example, we can write AI plus 1, or maybe you can use AI plus 1 minus AI. That will compute the difference between two adjacent elements. So we're going to see how to use array sort of in this problem. And here in this problem, we just use the integer arrays, but we can use the array, define array of any primitive type. So we can use a double, float, bool, char. So all of those can be done using similar syntax. Now going back to this problem, we are trying to, so one way to solve it is let's just enumerate through all combinations of 7 tuples, right? So there are all possible 7 elements. So one way to do it is actually to use 7 nested loops with 7 different loop variables. So here is the code. So we use an array X to store the 9 numbers. So this line read in the numbers. And then we use 7 different indices, A, B, C, D, E, F, G. So the intention is that these 7 variables will loop over all possible sort of combinations of 0 to 8. So then they will reference all subset of 7 numbers. So this XA, XB, XC, XD, XE, up to XH, these will go through all the subset of 7 numbers. And these the code highlighted in yellow is actually a fairly common idiom, but you probably don't see them this 7 deep in this way, because people will figure out some way to do it without writing a 7 deep loop. But 2 or 3 is very common. So this is enumerated through all combination of numbers in a range. So these 7 loops ensure that we'll be going through all possible combinations of A, B, C, D, E, F, G, where A is less than B, B is less than C, and so on. And all these values are in the range between 0 and 8. So A will go from 0 to 9, and then B will go from A plus 1 to 9, because we want to make sure A is less than B. So this way, every combination will be enumerated only once. And also, we're not going to have the situation where A equals B, because B always starts as 1 bigger than A. Similarly, C starts with B plus 1, and D starts with C plus 1, and so on. So this is a sort of a programming idiom that loop over all combinations of a value in some range, all pairs or all triples, in this case all 7 tuples of indices. So another thing that I want you to sort of to understand is to be able to parse this code, this yellow highlighted and blue highlighted code together. You understanding exactly why syntactically this is correct. So the blue highlighted portion of the code is a single if statement. So we have an if, we have expression, and then we have curly bracket. Within the curly bracket, there are 2 separate statements. One is to print out these numbers. The other is a return statement. So once we find one, we are done. So we return. So then this if statement is the body of the innermost loop statement. So this last loop statement. So remember that for every loop, for loop, after this for with this parenthesis part, we can have a single body statement. But sometimes we want to have more than one statement in the loop body. Then we use a curly bracket. So the curly bracket combine multiple statements and makes that a single statement. So now this if is the body of this innermost for loop. And then the innermost for loop statement, so for g equals f plus 1 until the end of this is the body of the previous loop. So again, this is a single statement, so I don't have extra curly bracket here following each for, because each of the body of each of the loop is a single statement. So in the outer loops, the single statement is another for statement. In the innermost loop, the body of the statement is this if statement. So there's all the curly bracket used here is necessary. So I'm not adding any extra curly bracket here. So I do that to make sure that you sort of understand how to parse this code, because sometimes in for loop we have a curly bracket, sometimes we don't. But there's a coherent logic into it. So following every for thing, there should be a single statement. That statement can be a compound statement, which are formed using curly bracket. Okay, so well, this code works, but actually, because we are using now, instead of having 9 different variables, now we're actually using 7 different loop variables. So in fact, we can use an array to store the 7 loop variables. So, well, I guess maybe you want to think a little bit of how to do that. I guess just spend a couple of minutes thinking about it, and then let's look at this code. I'm not claiming this version is better than the previous version, but it kind of illustrates the interesting usage of arrays. So instead of, so now we have 2 arrays. We have array X, which stores the 9 numbers. Then we have array K, which stores the 7 different indices that we're going to loop over all the array indices. So then the loop variable, instead of A, B, C, D, E, F, G, we have K0, K1, K2, K3, K4, K5, and so on. So these all, then the intention is this K array value will loop over all combination of indices. Here I use another sort of change to the loop structure to illustrate an alternative. So as you may or may not notice that in the previous loop, everything here is 9. So, but obviously, if the first value starts as 9, then there's nothing for us to choose for the second value. In fact, if the first value starts from 8, then if the first value starts from 8, then there's nothing to choose for the second value. We actually never go to 9. It's always less than 9. But if the first loop variable starts at 7, then the second one has to start at 8, then the third one has no value to choose from. So essentially, even if the first one starts at 3, second will be 4, 5, 6, 7, 8, then the last variable have nothing to choose from. So we know K0 goes to 3 or higher would never actually work. So we can sort of change that 9 here to 3. This will be logically equivalent to the previous version, but it will be slightly faster. This speed improvement is not really totally necessary. It's not really necessary, but here I'm just illustrating you can do this as well. And in fact, that this first loop variable, the body will only be executed when the first variable start at 0, 1, or 2, because then and the second one will be less than 4, and so on. So yeah, so here the innermost loop has a multiple statement, because now we need to we can use a loop to compute the sum of the 7 indices that we have chosen. So this is sort of the standard structure for computing sum. Initialize sum to be 0, and then now we can loop over from 0 to 6. Now we will add up the different x elements that are selected from the indices. So then Ki, so K is the array, I goes to 0 to 6. This will take the value from that array, and then we use that value as a reference into the X array. So if this little bit mysterious encourage you to sort of spend some time thinking through, we are essentially evaluating these expressions. I will be evaluated into some value, then ki will be evaluated into some value, then x of that will be evaluated into some value. And another thing that I sort of varied slightly differently is I declare the variable I here, so the loop variable. And because of that, I do not need to have an int here. So typically we write for int I equals 0, I less than 9 plus. So that means when we do that, we are declaring a new loop variable of integer type. But we don't have to do that. So we can declare the variable outside, and then this variable can be used for all the anywhere we need to use I, we can directly use it. So yeah, so then after if the sum equals 100, then we will print out these values, these 7 values. So yeah, I have this mainly to illustrate usage of arrays. It doesn't mean this version is better than the previous version. Now let's continue our analysis. So it's still kind of a little bit awkward or repetitive of writing these 7 tuples, and in fact. The question could easily be, out of 100 values, find the 98 of them that sum up to some value. So then this wouldn't work, right? So we wouldn't write a 98 deep loop. It's just too repetitive. So so we should do it some other way. So there is a more advanced way of doing it, which is using recursion to really avoid the repetition. But that's a fairly hard computing concept that I do not want to introduce now. But just for this question, there is another nicer way to do it by essentially having the observation that the sum of any 7 numbers will equal the total sum subtract the sum of any 2 numbers. So instead of enumerating through all combination of 7, we can enumerate through the combination of all pairs, so long as we first compute the total sum. So this illustrates the important point in programming is the requirement may be stated in one way, but you do not have to follow the stated logic to implement it. What you want to do is to find the equivalent logic that's easiest to code. So I think this is fairly important because I guess looking at the description and then just following it is fairly natural. But a lot of time, following it will result in very complicated code. What you really want is to find out something that's equivalent and easy to implement. So here is this code of just using a double loop. So these, in order to do this, we need to compute the total sum. So that we do that while we read data. So we initialize sum to 0. Each time we read in a data, we will add that to the sum. And then we double loop over I and j. And then we check if the sum minus ai minus aj, this will be the sum of the other 7 number equal to 100. Then we want to print out that 7 numbers. And we do that by loop through over all the indices. But we print out the number only if the indices is neither I nor j. So we print it out. And yeah, I think that's it.